Hello everyone, in this video we're going to find the sum of the following numbers. Let's start. First of all, let me write this sum in a general form, and the general form can be written as square root of 1 plus 1 over n square plus 1 over n plus 1 square. Now we'll try to simplify this expression. So then this is going to be equivalent to, so here the common denominator is n squared times n plus 1 to the power of 2. And the numerator is n squared times n plus 1 square plus n plus 1 square and plus n square. And as you can see in the last expression, the denominator is the perfect square, but the numerator so far is not perfect square. But here we have a possibility to express the numerator as a perfect square by using the following formula. We know that a squared plus 2ab plus b squared is always equal to a plus b to the power of 2. Now using this one, we'll try to express the numerator as a perfect square. Then this is going to be equivalent to the last expression. So the square root of, let me rewrite the denominator as it is, n squared times n plus 1 to the power of 2, and the numerator is, let me here express the first product as follow. So n times n plus 1 to the power of 2 and plus, and the second, this perfect square can be squared, so n squared plus 2n plus 1 and plus n squared, and this is going to be equivalent to, now here I can again rearrange the numerator of the last expression. So the first expression can be written as n squared plus n to the power of 2 and plus n squared plus n squared is 2n squared and plus 2n plus 1, and the denominator is simply n squared times n plus 1 to the power of 2, and this is going to be equivalent to, so therefore here I can express the numerator n squared as follow, n squared plus n to the power of 2 plus, so from these two expressions if I factor out 2, then I will get 2 times n squared plus 1 and plus 1, n squared plus n, and plus 1 divided by, so here n squared times n plus 1 to the power of 2. Now if we compare the numerator with this formula, then we can clearly see that numerator is the perfect square. So therefore this is going to be equivalent to square root of n squared plus n plus 1 to the power of 2 divided by n squared times n plus 1 to the power of 2. And as you can see, both numerator and denominator are perfect squares, so therefore the last expression simply is equivalent to n squared plus 1 as n squared plus n plus 1 divided by n times n plus 1. Now we can continue to simplify. So this one is equivalent to, so the numerator can be written as n times n plus 1 divided by n times n plus 1, and this the last one can be written as n times n plus 1 divided by n times n plus 1 plus 1 over n times n plus 1. So therefore this is going to be equivalent to, here this one is cancelled, and 1 plus 1 over n times n plus 1. And also this can be written as 1 plus 1 over n minus 1 over n plus 1. Now our general form can be written in a simplified form. So this means that, now let me here, if n is equal to 1, then this expression 1 plus 1 over 1 square plus 1 over 2 square can be written as, according to the simplified form, 1 plus 1 minus 1 over 2. And if n is equal to 2, then square root of 1 plus 1 over 2 square plus 1 over 3 square is equal to 1 over 2 minus 1 over 3. And if n is equal to 3, then square root of 1 plus, so here 1 over 3 square plus 1 over 4 square is equal to 1 plus 1 over 3 minus 1 over 4. And if n is equal to 4, then, so we see that this one is 1 plus 1 over 4 square plus 1 over 5 square is equal to 1 plus 1 over 4 and minus 1 over 5. And so on. So here, n, if n is equal to 1999, then square root of 1 plus 1 over 1999 square plus 1 over 2000 square can be written as 1 plus 1 over 1999 minus 1 over 2000. So therefore, here our sum can be written as original sum. So there, since this one is 1 plus 1 over, so sorry, simply 1 minus 1 over 2 plus this one is 1 plus 1 over 2 plus 1 over 3. And the next one is, let's write here, plus 1, so here, sorry, not plus 1 over 3, minus 1 over 3, and plus 1 over 3 minus 1 over 4, plus, and so on, plus, let me write here, 1 plus 1 over 1999 minus 1 over 2000. As you can see, these fractions will be cancelled, and here we'll have 1 plus, and so on, 1, and we can clearly see that here we have 2000 terms and minus 1 over 2000, and this is going to be equivalent to, we see that if we sum this once, then we'll get 2000 minus 1 over 2000. So this is our final answer. Thank you for watching. Please comment and subscribe to my YouTube channel.